So in this video, I'm going to explain how to construct reverted gate train in Adams. Now let us see that model name. You can use the reverted gate, reverted underscore gear. That is the title given for this exercise. And click apply and OK. Now let us see that reverted gear. The name is displayed. Now go to the point table. Click the because three shafts, 6 points are required. You can click the 6 times. So the 6 points are displayed. Now you can give the values x, y and z. Now I given z value that is 60, and the second point is 160, and for point 3 the x value I given the minus 160, and for the point 3 the z value is entered plus 160, and point 4 the x value is minus 160, and z value is minus 160. Now point 5 and 6 only that z value x and y are 0 zeros, and z value is minus 60 and minus 160. These are the data are given to create the shafts. Now apply, click OK. Now you can see the isometric view and fit to the screen. Now you can draw the shaft. Radius I am taking 20 mm. Just enter the 20 and select the points. Now let us, this is the first point, second point, the shaft is created. Go again the cylinder, again click the points, the first point and second point, second shaft is created. Again click this cylinder icon, and now the three shafts are drawn. Now the shafts are completely drawn with three different colors are displayed. Now the bodies change the name. So the part 2 that I am the input gear, the rename that is as a input gear. So the input underscore gear. That is the title of the first gear, input gear, because the motor is connected to this gear. Next part 3 is the intermediate gear. The name is accordingly intermediate underscore gear. Now the input power is transmitted input to the intermediate gear, and from intermediate to the output gear. So the intermediate underscore gear that is assigned. Next part 4 is output gear. Right click, rename and change the name, new name, that is the output underscore gear, because the space is not allowed. That's why I put underscore, output underscore gear. Apply and click OK. Now see that three names are assigned. Now go for the connectors. We have to connect each shaft to the revolute joints. Click the ground under this intermediate gear and the center, so that joint is assigned. Again this the input gear, ground and center of the shaft. You can select and click mouse button, then it will assign. Again we'll go for this joint, ground and output gear and center point. Then that joint will assign. You can see that with the help of mouse you can move it highlighted and click it. So once the three joints are assigned, next go to the machinery. You want to create the gates. That is here two set of gates are there. Okay, input gear to intermediate gear. Yes, several gears are there. I am using only spur gear. Just select the spur, go to next. Here coupler, simplified, detail is there. I am going to the detailed. Now here module I am changing 3.2. Then I just given the names. Gear 1 is the input gear. I just give the input and input gear, and second whatever the name you have to assign, that you have to write it, either input gear, and some mismatch is there. That's why the yellow color is highlighted. Once again re-enter. Okay, let us get, it doesn't matter, but just you have understanding. Let us put input and the intermediate. Let us, for gear 2 is intermediate, just write in that block intermediate, and you can choose the center location of the shafts. Okay, the first shaft center location I chosen, that is x value 0, y value 0 and z value is 100. And second gear, the center location I chosen minus 160 is x value, and the y value is 0, z value is plus 100. And then coming to the number of teeth for the input gear and intermediate gear, just I assigned number of teeth for input gear is 28 and for intermediate gear is 72. Gear width I'm taking the 20, bore radius also 20. So all gear widths are same 20. Bore radius is 20. Just next, then all the material values are displayed. Then select the gear 1. Here you can choose the fixed. The fixed, then you have to assign to that input gear. You see that input gear is assigned and second gear 2 is the intermediate. Again fixed, go to the body and here intermediate gear and click the next button, then finish it. Once finished with the given settings, the gear wheels are generated. Now look at this, these two gears are generated. Okay. Now similarly we want to create the another two set of gears. Again you can go for the detailed, next, and here I am going, the module is 2, and here it is a, now this input gear is intermediate gear and gear 2 is acting as output. Here you can type the intermediate and gear 2 is output, and you can choose the center location of intermediate gear and center location of output gear. Now let us enter the center location of input. Intermediate gear is minus 160 is X value, Y value is 0 and Z value is minus 100. Then you can select the center location of the second gear, that is 0, X value, Y value is 0, Z value is minus 100. And the number of teeth. The number of teeth here we are assigning the 32 in the intermediate gear, and output gear it's assigned 128, and gear width here also 20, here also 20, and the bore radius is 20 and here also 20. Then click next button. Now all the material density and modulus poisonous will be displayed. Here also gear 1, gear 2 we need to select. Gear 1 fixed, that is intermediate gear, select the intermediate gear, and gear 2 is fixed, that is selected to the output gear. Select the output gear and click next button and finish. The second set of gears will be generated. Now let us see that. It will take time because of that computation and everything it will take. Now let us see that here the second set of gears are, so this is the reverted gear train. Okay. Now let us see the different views, isometric views, front view, top view, and isometric view. Okay. So now here all the elements are drawn. Now we want to assign the motion to the input gear. Okay. That is a joint. Let us go to the connections, the joint 1. We are assigning the joint 1, modify, and click here. You can impose the motions. Click the impose the motions and select the rotation Z, rotation about Z axis, displacement. Just I have taken 60. Then click OK. Okay, 60 times D. The different values you can take, no problem. Okay, 60D. Click OK. And here the force display you can give that the on first body. So from first body apply the force and it will transfer to the second body like that. Okay. Now let us verify the simulation. Go to the simulation. Click this icon. Now you can different settings you can set. Here you can, I am going forever, and step size 0.01 I am selecting. Then verify the readings. It verified successfully. Close this icon. Then you can click this run button. So now you can see that the simulation is happening. So this is the reverted gain. What is the reverted gain? The axis of the input gear and axis of the output gear are the same. On the same axis, these two are rotating with the different speeds. Now let us see the analysis part. Go to this windows, and right side you can load the animation. Top left side window you can select any one body, that is you can go for select the objects. Here you can select the body, and I am going to see that output gear. For output gear or intermediate gear, I want to know the angular velocity. Just I have to collect the angular acceleration, magnitude, and the add call. So whatever you want, that you can add, like the same procedure you can use it, and you can add the calls. And the second window also it will be happening. How many you want? The same window, you can another, if you want, you can select it. Now let us see that another is also obtained. Like that, several velocities you can analyze using this process. Now let us see that how the angular velocities or angular accelerations of the different gear wheels, that is the input gear, intermediate gear and output gear, whatever you want, that you have to analyze using this process. Whatever this in this graphs also, in between how it will looks like, that also you can, that settings are there. With that settings also you can set, and again go for the play, and it will play. Okay, now let us see that gear wheels are rotating and the processes are going on. Okay, so you can compare them. Very useful to analyze